but I'm here to talk about data science and Snap. We've seen a couple of few things so far involving some cool visualizations, but I've created, as a part of my master's project last year, a library within Snap to be able to teach introductory data science content to high school students. So we're really trying to get this content out to high school teachers to be able to expose as many students as we can to this kind of work. So DASIS is the first comprehensive data science library in Snap for beginners. Because Snap is very beginner friendly and visually oriented, it's a fantastic language to be introducing this kind of content to students. They'll be able to learn data science principles without having to spend a significant amount of time learning how to use Snap. As we all know, Snap is very intuitive, it's very beginner friendly, and these were all reasons why I began undertaking this project in the first place. I personally learned how to code in Snap. I taught people how to learn in Snap. I cannot stop speaking its praises, and that's why I committed my time as a master's student doing research in it. And data science is very interdisciplinary, so it applies, its principles apply to almost any student, any interest, any major. All of these, basically all students will be able to take advantage of the work that I've done here. All of my work that I've done so far is available at this URL. It's under CS10's sort of big umbrella, and it's currently being workshopped as a course called Beauty and Joy of Data Science. All of these student-facing modules are present there. You can click through them yourself. You can take a look. And the mini course overall is accessible for anybody, any student or any teacher who has an internet connection and a Snap account. So a little bit about me. I just graduated with my 5th year master's in EECS from UC Berkeley under Professor Josh Hugg. I completed my undergraduate degree at Berkeley with a major in computer science and a minor in data science. I've TA'd various CS and DS courses, including under the fantastic Professor Dan Garcia, and I'm the sole developer of this library, but there are plans to continue the project with other undergraduate and graduate students in the future. So currently the DASIS library includes table infrastructure, the ability to import CSVs for students to be able to interact with data directly. They can import CSV files, or they can create their own tables from scratch for smaller tables if they just want to play around in a bit of a sandbox environment. There are table methods that are not limited to select, order, and limit. Basically, the entire suite of querying methods are available. And there are also table manipulation functionalities for adding rows, removing rows. Same thing with columns. You can group, you can pivot, you can do all sorts of cool stuff with these tables. There's also functionality for data visualization. We have bar plots, histograms, line plots, and scatter plots. All of these are fully functional, and they are able to use with the simple click of a button. Students don't have to do as much work molding the table correctly into the format that it can be visualized. It's intended to be a very abstracted one click and generating the visuals. So to use DASIS, it's not currently available on Snap's interface, although hopefully in the future it may happen that it'll be importable for students to use. Right now, it can be found on the link that I mentioned earlier. You can download the XML and import the blocks manually. The way that we prepare tables is either, as I mentioned, from importation, or we can also create tables from scratch. And students will be able to interact with these table objects and attributes as they please. I created very little oversight for those kinds of things. They have the liberty to interact with it as much as they'd like. And as I mentioned, we have table visualization, table methods, we have data visualizations. We have a lot of things that students in practice have really enjoyed interacting with. So we can import the data using a variable in Snap. So you create a new variable, you right click the area on the stage where the variable appears, you can click import, and that allows you to bring the CSV into your Snap file. That allows you to import the data, and it comes in as just a raw CSV file. Then we can create a table object with the DASIS block required to do that. It will turn it into something that looks like this, the photo at the top right, where it gives some attributes. It's an abstracted data structure. Students don't need to really know how to use that. They just need to be able to use these 4 reporters on the right, and that will allow them to use all the information that they need. There are several different accessors that they'll be able to use, not just these 4, but there are many different queries and different accessor combinations that they can use to learn information about their tables. So querying the table is very similar to SQL style queries where students can chain a bunch together. They can do 3 at once. They can do 1 at a time. All of them work the same. There is no difference. And students don't need to understand what's going on under the hood. They don't need to understand why a select works or an order or a limit. They can just use the blocks abstractly to do the jobs that they need to do. So with querying, this is where I'm going to start kind of patching in the demo as we go. So these are some examples of querying blocks, and I actually have a bit of a demo prepared here. So as I mentioned, we can view a table. This is what a table object looks like in DASIS. We have the data itself is all these lists up here. Then we have the number of rows, the number of columns, and then the labels of those columns. And when we use the view table block, this allows us to see the data as a student would expect to see them. So we have the column labels at the top in all caps to make sure that students aren't confused if that's a data point, if it's not a row in the table, and all of the data is present. So we can access the table. This is how students would be interacting with it. We can ask for the number of rows. We can ask for the number of columns. We can ask what the column names are. These are all simple accessor methods for the object, but students do not need to be interacting directly with the table object. They can always use these accessor methods to take care of the abstraction underneath. We can ask for a particular column. If we want to know the island column, this gives us all of that information. If we want to know the first row, it will give us the first row. These are just a few of the things that students will be able to do once they've gotten comfortable using the table object itself. Once they get to that point, we can start using some more complicated queries. So in this case, we're selecting the island and species from the data, and this will give us just the 2 columns that we request, or however many columns that we would like to request, whether it be 1 or whether it be many. We can also do a keep. And the way this is structured is that we can keep the rows from the data where the sex is equal to female. So we get all of the female penguins in this resulting table. And all of these queries that are reporter blocks are not permanent. So the original data is still fully intact. Students don't have to worry about overwriting their data or accidentally losing rows or columns. All of the reporter queries will maintain the original structure of the table. We can also do a keep saying that we want the flipper length greater than 207. And we can see that a large portion of those penguins are Bisco penguins, or they come from the island of Bisco. A few sneak in, but in general, we're going to talk later in this demonstration about how this could parlay into a sort of machine learning conversation, as we just saw with Brian's presentation. We could also order the table. So we order the data based on body mass, and it's in descending order, and that's going to give us the table in descending order of body mass. All right, we also have some functionality for applying functions. So if I want to view the original table, that's actually not supposed to be there. If we want to view a column like body mass, and then we want to convert it to kilograms instead of grams, we can do that with the apply, and that's going to give us all of the different body masses of the penguins in kilograms instead. There are a few other things like adding and deleting columns, but the most important part about these command blocks here, they say permanent from time to time. If you use a command block query, those are going to be permanent. Those are going to change the original table. So I always told students, make sure you remember to save your original table before you go and do one of these things if you're not sure what's going to happen, because it is difficult to recover old data once you've overwritten it. All right. We also have what I think is the coolest portion of this functionality, which is the data visualization. I am a huge data science proponent. I really enjoyed learning about it. I enjoyed teaching it. And data visualization was always one of the coolest things that I got to teach students. And I'm so happy to have been able to bring that into Snap in a very data science, Python data science library friendly way. So as I mentioned, we have bar plots, histograms, scatter plots, and line plots. All of these things can be used by students with one click. They don't have to worry about having the right table or the right columns. As long as they use the columns correctly, they will get a resulting data visualization that looks very cool, in my opinion. So if we have something like this where we group the table by species, and I don't know why it's getting upset about that, but we're going to see if just subbing that out may help. For some reason, we're having a problem. This was a bit of the problem that I was having earlier. For some reason, it's not recognizing Penguin data as a. I am very sorry. Well, I could just create the call myself. So if we were to use the horizontal bar function, which is here, and I could grab that, we'll move that a little bit over just for the time being. I don't know why this is getting so upset.
Isaac, I'll point out you have 5 minutes left.
Thank you. I don't know. I've demoed this quite a few times and I've never seen a problem like this. My sincere apologies. We just went over this. It was all. I'm baffled.
Maybe you just need to group it by something.
It's that it's not recognizing the variable anymore in Snap. It's saying that my variable, which as all of you just saw was existing and working, is not working anymore. Seems like none of these
use JavaScript.
Yeah, it seems like none of these variables want to exist anymore. Huh. Well, I'm very disappointed that I don't get to show these off. I don't exactly know what's happening.
Can't you just refresh the page?
Yeah, I think I may just have to. Here, one moment. Let me see. Let's see now. I seem to have it up and running. So Penguin data should exist. If I grab bar graph. On Penguin data. This is absolutely unknown to me. I could try and do this. I could load it in a different Snap window, in a different Snap file. That may work. Let me see.
Isaac, I'll point out in the chat, Michael asked if you have an XML file you can share with us, and Bernat.
Yes, I do. So I can
Trying
actually
to-
share the link to my course content, which I also wanted to show off. I can share the link to that in the chat.
And then Bernat also pointed out to try on V7 Snap.
So students can see underneath. I see a question in the chat. Students can see underneath the blocks. They can understand what's going on, but it's not necessary for them to be able to use the library. So they could absolutely break open the blocks, see what's going on, see how everything works underneath, but it is not mandatory for them to be able to understand the data science principles. And this has also been demoed to a class of about 30 students. And the feedback was very positive. It was a teacher in the Bay Area, Sean Morris. You may know him from various Snap relations, but he had a very positive experience teaching it to students. Students gave very positive feedback. And for any high school teachers or high school educators who would be interested, always feel free to reach out to me, and I can talk to you about any of this stuff at length when things aren't going awry as they are now.